Here in example 11, we're working with one of those piecewise functions we talked about just a second ago. We have a function g, and it's a blend of two others. It's a piece of, it looks like a line, it has negative x to the first power, plus 1, and then we're doing it with a parabola, so we have that x squared term in there. Okay, so it's a blend of two different graphs, and when it says using the graph, we want to find the domain and range. Okay, so let's break this down into the two pieces we know. Remember, g of x just stands for y, so we have two parts. We have y is equal to negative x plus 1, and the second part is y is equal to x squared minus 1. Okay, so two different t-charts here. And we're going to go to that right part to tell us what to plug into our t-chart. We can't just pick any x value. We have got to follow these two parts right here. Okay, so for part 1, it says I can pick anything smaller than 1 and equal to it. Whatever number they put here, I always want to start with that. So I'm going to start with 1 and then pick anything smaller. So let's go 0, negative 1, negative 2, and so forth. Okay, on the next one, it says I need to start at 1 and go larger. So 1, 2, 3, 4, and so forth. The only difference is I can't equal 1. So when I get to this point right here, I want to make sure I do an open circle. On the top one, I can equal 1, so I'm good. It's going to be a typical closed circle. But on the next one, again, whatever number they have here, start there in your t-chart and just go accordingly. If it equals it, great. If it doesn't equal it, just write yourself a note, do an open circle. Always, always, always do that. Okay, so let's plug in 1 into that first equation. So negative 1 plus 1 is 0. Negative 0 plus 1 is 1. A negative, watch this, negative 1 plus 1. So 1 plus 1 is 2. A negative 2 is 2 plus 1 is 3, and so forth. Okay, let's go to the next one. 1 squared is 1, minus 1 is 0. 2 squared is 4, minus 1 is 3. 3 squared is 9, minus 1 is 8, and 15. Okay, let's put these together and draw ourselves a graph. Okay, just kind of listing out our points that we have so far. All right, I'm going to draw, let's say, I'm going to draw this left part of this piecewise function in green. So it looks like the line. I have the point 1, 0, 0, 1, negative 1, 2, negative 2, 3. That's looking good. I said it looked like a line by the equation, and it's like it's following the dots. Now, I want to be very careful. I'm not going to draw a straight line through all this. I'm only going to draw a line up to that first dot I drew, because remember, this line can only start at 1 and go left, so it has to be x value smaller than that. Okay, on the next part, let's do this one in the red. It says I have an open circle at 1, 0, but since it's closed because of the green, that green's going to trump it. Okay, then at 2, we're going to go up to 3. At 3, we're going to go up to 8. And if we did 4, we'd be all up at 15. So we're going to kind of curve up like that. And those together make one big graph, one big function. So the answer as far as graphing it is all of that is one big unit. Okay, so now that we can see all of that, let's find the domain. The domain says how far left is that graph going and how far right is it going. Well, it looks like the green portion is telling us how far left. And that arrow is showing me, wow, I'm going to go forever left, so it's going to be negative infinity. And the red, as it's going up, it's spreading to the right, so it's going to go to positive infinity. The range is down to up. Okay. Well, the lowest this point ever gets to, as I go far, far, far down, the lowest it ever gets to, it looks like a y value of 0. In one time it's an open circle, but the other time it's a closed circle. So because one of them was closed, we can do a bracket. And the highest we're ever going to get to, the green as it spreads left, it's going up. The red as it spreads right, it's still going up. So we're just doubling up and going up to infinity, just like that. Okay? Let's go on to the next topic on how to work with several functions at once. You know how I told you when we first talked about interval notes or function notation that the letter out front was just a way to name them? Well, look right here. We have 3 of them up there. And that way, if I can say, hey, let's go to function h of x, you know which one I'm talking about. It's just a way to name them. Instead of going just 3 general equations, I wouldn't have to list out the whole thing. I say just go to h of x and you can see. And what we're doing here is just doing basic algebra with multiple functions together. This first one says f plus g of x. What that just stands for is taking your f of x function and adding on your g of x function. What they've done is instead of writing the of x part, instead of writing it twice, they only wrote it once. This does not mean take your f function, add on your g function, and then multiply by x. I want to reiterate, that's not what that means. All it means is just focus on what's here in this parentheses. Just add the 2 functions together. So what we're going to do is just go to my f function, which is x squared minus 1. I'm going to take that function and add on my g function, which is x minus 5. So together, when we combine like terms, the answer is just x squared plus x minus 6. It's as simple as that. That's all your answer is. We're not multiplying it again by x or anything like that. It's just whatever's in that first part, that's what we're going to do. All right, so when we go to the second, it's saying fh. Well, they're right side by side, so we're going to obviously multiply. This is the same thing as going f of x times h of x. Okay. So cleaning this one up a little bit, our f of x function is x squared minus 1. Our h of x function is the square root of x plus 3. So when I distribute all this out and multiply it together, okay, when you have radical part with a non-radical part, non-radical goes out front, so it'd be x squared square roots of x. The outside would be plus 3x squared. Inside would be minus the square root of x, and then minus 3. And right there, since everything really is not like terms at all, that is the answer for that part. Okay, now I have a brand new notation on this next one that we're probably not used to seeing before. It's f, and they have a circle in the middle of it. It's f of g of x, and how you can read it as like this. I tend to use this more notation. You know, normally we can see something like find f of 2, and whatever's in this parentheses is what we're plugging in for the variable. Well, look what we're plugging in for the variable this time, a whole new function. Okay, so follow me through this and I'll show you how we're going to do this. So f of g of x is the same thing as going f of, and what is g of x? It's x minus 5. Okay, all I did was instead of write g of x in here, I wrote what g of x equaled, was x minus 5. So what I'm going to do is in the f function, wherever I have a variable, I'm going to plug x minus 5. So going up there to the f function, where I have my variable is right there, I'm going to write that as, instead of x squared, I'm going to have x minus 5 squared, and then minus 1, just like that. Okay, so let's just talk about this for one more second. It says, over here on the left, you want to find f as a function of g of x. Okay, so if you want to take that away, just replace it with what g of x equals, which up there is x minus 5. Okay, so now what I'm going to do is I'm going to go to my f function, just focus on the x function, and wherever I see my x variable, right there, I'm going to take that away and put whatever is sitting in this parentheses. And then all you have to do after that is clean this up and you're finished. I'm squaring a base that has 2 terms, so x minus 5 times x minus 5, and then minus 1. So the answer here is x squared minus, outside and inside give you a 10x, plus 25 minus 1. So all in all, when we combine this together, then f of g of x, so when I plug the g function into my f function, I get x squared minus 10x plus 24. And there's the answer. All right, let's try this one more time with another pairing. It says in this one that I'm now going to do a pairing up. I'm going to pair the function f function with the h function. Okay, so f of, instead of h of x, I'm going to write what h of x equals. H of x is the square root of x. Sorry, let me shorten that radical sign. Okay, h of x is the square root of x plus 3. So I'm going to go back up to my f function. Wherever I see the x, which is, it says x squared minus 1. Well, instead of putting an x, I'm just going to put whatever's sitting in this parentheses, which is the square root of x plus 3. And then from there, all we have to do is clean this up. Okay, this base has two terms, so we got to write it out twice. So square root of x plus 3 times the square root of x plus 3 minus 1. Foiling it out, square root of x times the square root of x, we decided that was just x. This is the square root of x squared, which is x. Outside and inside will give you 3 square roots of x and another 3, so a total of 6 square roots of x. And 3 times 3 is 9, and then minus 1. So all together, f of h of x, when I plug h into my f function, you'll get x plus 6 square roots of x, and then plus 8. And there's my answer for that one. And getting a little bit more practice with combining functions together, let's just look at number 13. I have an f function and a g function. This first part right here is just telling me that I want to subtract them. Simple as that. I'm not subtracting and multiplying by x, I'm just subtracting them. I'm only following what this first part tells me to do. So I'm going to take my f function, which is x over x squared plus 1, and I want to subtract 1 over x. Okay? Just working here, we just want to get a common denominator. When they're different like that, the common denominator is just things multiplied together. So it'll be x times x squared minus or plus 1, and another one of x times x squared plus 1. Whenever they're different, just multiply them together. Well, that first denominator needed the extra x, so I'm going to put the extra x in the top, making it an x squared. In the second fraction, I had the x, but I'm missing the x squared plus 1, so I'm going to take whatever was in that top and multiply by the whatever I needed to add to the bottom. Okay, so now that we have a common denominator, let's just go across the top. It's saying x squared minus x squared plus 1 over that denominator, and making sure that I distribute correctly. And x squared minus x squared goes away, and then we have left a negative 1. Make sure we have that negative in there because I need to distribute both the negative to the x squared and to the 1. And then over x times x squared plus 1. And there's my answer when I subtracted those two rational functions. All right, let's go to the second part. In the second part, instead of just subtracting them, we're going to blend them. We're going to do the composite function. So now it's going to be f when I plug in g of x. So let's take away the g of x and set what it equals, which is 1 over x. Okay, so let's go to the f function, and wherever I see a variable in the top and the bottom. So I have wherever I see the variable, I'm going to put whatever's sitting in this parentheses. So up there in the top, I'm going to put 1 over x. In the bottom, it's being x squared plus 1. So what's in this parentheses is 1 over x. Okay, so now from here, it's just cleaning this up. 1 over x divided by 1 over x squared plus 1. At that step right here, all we want to do is to get rid of the complex fractions. So we go to the denominators. The denominators have an x and an x squared. And we want to multiply the top and the bottom by whatever the LCD would be. Well, the LCD between x and x squared, since they're both common terms, they're not different like what was up above. They're exact same, so what we're going to do is choose the higher powered. So I'm going to multiply the top by x squared over 1 and multiply the bottom by x squared over 1. So x squared and x, what's going to happen here, let me change colors just a little bit. X is going to cancel with one of those, just leaving me an x in the top. X over 1, which is x. And here, when I go x squared times 1 over x squared, the x squareds cancel and I just get 1. And then when I go x squared times 1, I get x squared. And there's the answer when I find f of g of x. It equals that fraction right there, and that's all we can do to it.